Hi and good evening. So for today's video, my group will be presenting about application of differentiation, which is related rates. First of all, I would like to introduce three of our group members, which are Alessandro Marcelo Ewin, Sarah Michelle Joseph, and Putri Azian Izati binti Izani. What is differentiation? Differentiation is a mathematical method that deals with a rate at which the function changes. There are four methods used to find a function derivative, which are product rule, power rule, chain rule, and quotient rule. Related rates. Related rates deals with finding the rate at which one quantity changes with respect to another related quantity. It involves using derivative how to calculate how two or more variables changes in relation to each other over time. Why we need to use related rates? We need to use related rates to analyze the changing quantities that are interconnected. Second, it helps in solving problems where the rates of change of different variables are involved. Next, it will gain the insight into the dynamic relationship between these changing quantities. There are few common questions about related rates. Related problems often involve finding a rate which on quantity is changing with respect to time, given the rate of change of another related quantity. The common question that might involve is geometric shape and fluid dynamics.
Okay, daily life application of related rates. So, calculate the rate of change is crucial in various daily life scenarios. So, how long will it take to fill one bottles, monitoring gas mileage, and adjusting the heat on the stove.
So this is our problem statement that we choose, which is a contractor wanted to fill his full tanker truck for his worker. The contractor fills his truck at the nearest gas station, which is Petronas. If the oil flows out into the tank at a rate of 30 meters cubed per minute, at what rate is the height of the gas in the tank changing when the gas in the tank is 1.2 meters deep? So the diameter of the cylinder is 2.5 meter and the height is 6.7 meter.
So here I'm gonna solve the problem. So first of all, the question has given us the value of rate of oil flow out into the tank, which is 30 meters cube per minute, and the question asks us to find the value of dH over dt. So the question given us the height of the tank truck, which is 1.2 meters for this value. Okay, next. Okay, dH over dt equals to dH over dV multiplied with dV over dt. So before that, we need to find the value of R, which is in the value of H. So like this maths word, R over H equals to 1.25 over 6.7. So multiply both sides with H. So we're gonna get R equals to 1.25 over 6.7 height or H. So okay, we need to state the formula of volume cylinder, which is pi multiplied with R square over multiplied with H or height. So we need to substitute the value of R, which is 1.25 over 6.7 H in the bracket of power in the bracket of square. So we're gonna get the answer is 625 over 17,956 H square multiplied with pi. Okay, so next we're gonna get the value of dV over dt is 1085 over 17,956 multiplied with h square multiplied with pi. Okay, so dH over dt equals to 17,956 over 1,875. So So we need, before we enter for this equation, we need to inverted formula, which is dv over dt. We need to transform the dh over dv. We need to transform the previous word into the dh over dv. So we're gonna get 17,856 over 1,875 h square pi, and we need to multiply the equation with 30, which is the height is 30. So the 30 is the rate of the oil. So next, okay, we need to substitute the value of h, which is 1.2, as the equation given to us, 1.2. Okay, so we multiply all the value inside, so we're gonna get 538,680 over 1,875 multiply with 1.44 pi. So we multiply the value all inside, so we're gonna get the dh over dt is 413.7062 pi meter per minute.
So, for the conclusion, the concept of rates of changes is integral to understanding various aspects of daily life. The ability to calculate and interpret rates of change adds a valuable dimension to problem solving and strategic planning. Thank you.